We will lightly touch upon the BOM data model so you could understand how to gather BOM report when writing a DIN, and also I will show you how to create the DIN that exports BOM data to some custom database. So how do you get BOM reports? Well, first, Woodwork for Inventor calculates BOM and opens it in BOM app. Then user selects the template and exports that data to Excel or text file, or commits it to Autodesk Vault Server. But what if user needs to export data to some other systems like ERP systems or databases, or for example, to some cutting applications? Well, some of our customers uses text or Excel files generated by BOM app to transfer data to third-party applications. But this is not very convenient and it's not possible in all cases. So in that case, we can enhance the functionality of BOM app by creating an add-in, which is essentially a simple DLL file. DLL stands for Dynamic Link Library. This add-in can be invoked by BOM app, and it will communicate with other applications, enabling direct data export from BOM app to other systems. So our main topic today is how do we create that DLL file. Well, the process of add-in creation requires a skill set beyond that of a typical BOM app user. So this task is not intended for the French designer or constructor in a company. It is assumed that the individual creating the add-in has some experience with a C# programming language and is familiar with using Visual Studio or Visual Studio Code tools. So these aspects will not be covered further in this presentation. However, I will aim to keep the C# code as straightforward as possible to effectively demonstrate the fundamentals of add-in creation. So let's see how to create some add-in. My daily work tool is Microsoft Visual Studio, so I will use it here now to create the C# project for our new add-in. Let's create project. As I said, our add-in is basically a DLL file, so we can choose whether class library template or WPF class library. I will choose this one because I want to show some friendly user messages in my add-in. Click next, give it a name for our project. And in next page, we choose the latest .NET Framework version as BOM app supports it. So now we have our C# project, which can be compiled to a DLL file, but it is not the add-in yet, yes? To make this project to work as an add-in for BOM app, we need to add a reference to a specific DLL file that is included in the Software Development Kit or SDK folder within our application. This DLL file essentially acts as a bridge between the add-in and the BOM app application. It provides a set of functions that enables the add-in to communicate with the application. So let's add the reference to this file in our C# project. I will just browse to installation directory of BOM app, and here we have an SDK folder. And in this folder, we have some demos and this API DLL. Let's select it, okay. And so now we added a reference to this DLL, we can see it here. And with this DLL, we can have the shell APS namespace in our project, and we will use IBOM add-in interface. Well, our Visual Studio is not very happy because we're using this interface, but we did not implement it. So implementation is quite simple. It's just one method in it. So how it works? When user in BOM application runs the add-in, this method will be invoked, and basically that's it. And to demonstrate let's create some message. That's why I choose the WPF template and message hello from my add-in. Okay. Now we shall compile our project, and in the output window we can see the path where our DLL file is compiled. We will need to provide this path to BOM application, so it will know where our DIN is. So just copy it to clipboard and start the BOM application. As you see, I started the BOM application already with some model data in it. But how to run the DIN? Well, first we need to go to Settings, DINs tab, and enable a DINs, and we have an empty list for now with all our DINs. Let's just add the DIN that we just created. We just paste the value of this path to our DLL. Okay, we can set some custom name for our DIN. Let's just leave the default one, save, close. And now here in the header of BOM app, we have one more drop-down button, and in this drop-down menu we will have all the DINs. And here's my DIN that we just created. Let's execute it, and here we see the message, hello from my DIN. Well, it works. Now let's see how can we to gather data, this BOM model data, in our code. Okay, let's close it. Well, as we see, the init model, init function provides this BOM app object. This object implements communication with BOM application, and we can use it to get data from BOM app. For that, we will use property BOM, and BOM property returns object of type BOM. BOM equals BOM app BOM. Yeah, it's just simple. So what is this BOM property? Let's take a closer look at it in our presentation. So BOM property gives us data model that is currently opened in BOM app, and it has two properties, header and children. Header property contains some general data about BOM, like customer info, constructor info, and so on. And children property returns collection of item occurrence objects, and basically it's the contents of our BOM report. Be aware that BOM children property returns only first level of BOM tree representation, and usually it will contain one item, and in our example it is the item representing the root node of bed assembly. So each child in children collection is an item occurrence, and it is the object that defines child element in item property. Its quantity, and it has some other properties. And item defines the concrete BOM item. It can represent a document like part or assembly, workpiece or material. So it has properties defining this object like name, code, type, and others. Also, each item has its own children, just like BOM object. And that property returns collection of item occurrence objects that belongs to item. So it's just some recursion. So bed object is child of our BOM. Pull drawer is in the children collection of bed item, and children property of pull drawer item will return item occurrences contained by pull drawer. And that's how BOM tree is constructed in our data model. So with that knowledge, we can iterate the BOM, and for demonstration, let's get names of all items in our BOM. So how can we do that? Well, as we saw, BOM returns collection of item occurrences. I will declare this variable explicitly for better understanding. Item occurrence array. Yeah. And we have array, we can iterate it. And I will do that in a new method. It's not created yet, so let's create it down below here. And to iterate the array, we use simple for each loop. So from item occurrence, we can get an item. And from that item, we can get string value of name. As we can see, IntelliSense suggests us it has some more properties like name, code, BOM IDs, children, PDM type, and so on. We'll just use name. And what can we do with this name? Well, let's add it to some class variable, create it here, where we'll keep all names. And we will show these names instead of hello message right here. So to add this name to our names list, just sign like so. And I will add a line ending for a nice looking list. I hope you understand everything now. So now here we iterate through all items in our BOM object, but we do not iterate through the children of this item. So how do we do that? We just call this same method, iterate, and this time we provide children of our item object. Yeah, that's basically all. Let's build our project. And let's try open the same model in BOM application and run INDIN. So, and what do we have here? We have a very long list with all items. Want to close it. And okay, it doesn't fit my screen even. Yeah, why is that? Well, because this model, I will expand it all. It's not very little. So what can we do? Well, let's get rid let's just keep only document objects, okay? So assemblies, part documents, and purchase documents, purchase parts. Okay, so how can we do that? Well, every object in our BOM is an item object. So let's take a closer look at what is this item. So item basically is an abstract type, which can be a document in our BOM, a workpiece, or material. And this document can be whether assembly document, whether part or purchased item, it's a quantitative item. Workpiece can be a fill material workpiece or cover material workpiece. So in order to filter assemblies, parts, and quantitative items, we just check if our item is document or not. That's so simple. Okay, so let's open the code again and just check if item is document. If item is document, only then we will take its name and iterate its children. Let's build our solution again. So our DLL library is to build it. And run BOM app. So now we have the same model, run it in, and we see the list is quite shorter. We don't have any materials or workpieces in it. Well, that's great, but that's not very useful, yes? So let's commit these items to some external database, okay? So we will simulate a real-world scenario. Well, let's close the BOM app. And for this purpose, I prepared a small database in Microsoft Access. I will open it. And this database has just one table, which has columns like name, code, quantity, length, width, and thickness. So in our DIN, we need to connect to this database and add data. As we added a reference to BOM API DLL for our DIN to communicate with BOM app, we need to add some reference to a package so our DIN can communicate with the Access database. I will open our project file. We see this code that was generated by Visual Studio when we added our BOM API DLL. And to connect to Microsoft Access database, we will add this package reference, OLADB. This package reference comes from, well, you need to check documentation for each system that you are referring to. Well, if you work with Autodesk Vault, this line will be different. If you work with some ERP system, you will have to check the documentation for ERP system. I just Googled it, how to connect to Microsoft Access database in C#, and Google gave me these results. So basically that's it. Now we save this project file. Now we can connect to our Access database. How can we do it? Well, we will not need these property names. Instead, we will need connection. It is already connection provided by Microsoft. Yes. We have connection, but it's just a variable, and we need to connect to our database. So let's do it in the beginning of our method. And that's how we do it. We provide a path to our database file in connection string, and we use this connection string to just connect to database. And of course, at the end of the function, we need to close this connection. And in message box, instead of names, let's just leave an indicator to say that everything is done. Okay, so we connected to our database, we iterated through items, and we close the connection. That's it. Only in the iterate method, instead of collecting names, we will just need to commit item, yeah? Commit item occurrence to database. So in this loop, we will commit each item occurrence to a database. We don't need this variable. And let's create the commit method. Well, commit method, it's a bit tricky maybe, but I hope you will understand it. So to commit to database, we need to create a command, and we need to assign a command query for it. If you are familiar with SQL queries, so that's basically a SQL query, which tells database to insert into table items. We provided the column names for that database, and we provided arguments for values. Yeah. Now we have to provide the values for those arguments. So name and code can be taken from item object, which can be taken from item occurrence. So let's take item. And let's add name to our command parameter. Okay, for name, we use item.name. Okay, and with the code, we can do the same. And for quantity value, we can use quantity that is taken from our item occurrence, because item is it's just a definition of item, and item occurrence defines the position, the parent-child relation, and it knows how many items are in parent. It's quantity, yes? Okay, but other properties like length, width, and thickness, they cannot be found in item. Yes, if we ask for IntelliSense, there is no such properties like length, width, thickness. So how do we get them? Well, let's, as I mentioned before in this slide, our item can be with a document, any of these objects, and I know that only part of the documents has size properties. So as we checked if item is document, the same way we can check if item is part, and we take its size in that case. Okay, so if item is part, declare a variable, then in such case item has size. And now we can provide the values for part, length, and thickness parameters. Yes, size length, size width, size thickness. And in case the part is not in case the item is not part, we need to provide some default values so our command query would not crash. So just provide db null values. And basically that's it. Our query is completed, command created, and all we need to do just execute that command. That's it. Let's build our DLL one more time. Let's go back to BOM application and run a DIN. It says done. Okay, just like we asked. Now let's check the database. Open items table, and we see that all items that are in our BOM are here in database committed with quantities, with length, with thickness parameters, and so on. So, in the last 20 minutes, we created the C# project to build the DLL, implemented the DIN logic, and retrieved data from BOM application. Then we implemented the communication to Microsoft Access database as a third-party system and successfully committed our BOM data to it. And now user can do it with a single click in BOM app. It was quite a simple example, and I believe that it will be much more complicated in real-world scenarios. But I hope this example provided you a good understanding about the API of BOM app. So you can find some more examples in SDK folder and more detailed documentation in our online help. Also, you can always write to our support team if you have any questions. And maybe you have some questions now that I can answer. Well, if no, that I'll take it as a sign that I was able to explain everything very clearly. Yeah? Okay, so that's basically it for today. I hope this presentation was informative and helpful for you, and thank you for your time and attention today. Don't hesitate to reach out if you have any questions in the future. And goodbye.